A series of light curves from Webb's near-infrared spectrograph, NIRSpec, shows the change in brightness of three different wavelengths of light from the WASP-39 star system over time as the planet transited the star on July 10, 2022. A transit occurs when an orbiting planet moves between the star and the telescope, blocking some of the light from the star. This observation was made using the NIRSpec Prism Bright Object Time Series mode, which involves using a prism to spread out light from a single bright object, like the star WASP-39, and measure the brightness of each wavelength at set intervals of time. To capture these data, Webb stared at the WASP-39 star system for more than 8 hours, beginning about 3 hours before the transit and ending about 2 hours after the transit was complete. The transit itself lasted about 3 hours. Each curve shown here includes a total of 500 individual brightness measurements, about 1 per minute. Although all colors are blocked to some extent by the planet, some colors are blocked more than others. This occurs because each gas in the atmosphere absorbs different amounts of specific wavelengths. As a result, each color has a slightly different light curve. During the transit of WASP-39b, light with a wavelength of 4.3 microns is not as bright as 3.0 micron or 4.7 micron light because it is absorbed by carbon dioxide. A transmission spectrum of the hot gas giant exoplanet WASP-39b captured by Webb's near-infrared spectrograph on July 10, 2022, reveals the first clear evidence for carbon dioxide in a planet outside the solar system. This is also the first detailed exoplanet transmission spectrum ever captured that covers wavelengths between 3 and 5.5 microns. A transmission spectrum is made by comparing starlight filtered through a planet's atmosphere as it moves in front of the star, to the unfiltered starlight detected when the planet is beside the star. Each of the 95 data points on this graph represents the amount of a specific wavelength of light that is blocked by the planet and absorbed by its atmosphere. Wavelengths that are preferentially absorbed by the atmosphere appear as peaks in the transmission spectrum. The peak centered around 4.3 microns represents the light absorbed by carbon dioxide. The gray lines extending above and below each data point are error bars that show the uncertainty of each measurement, or the reasonable range of actual possible values. For a single observation, the error on these measurements is extremely small. The blue line is a best fit model that takes into account the data, the known properties of WASP-39b and its star and assumed characteristics of the atmosphere. Researchers can vary the parameters in the model, changing unknown characteristics like cloud height in the atmosphere and abundances of various gases, to get a better fit and further understand what the atmosphere is really like. The model shown here assumes that the planet is made primarily of hydrogen and helium, with small amounts of water and carbon dioxide, and a thin veil of clouds. The observation was made using the NIRSpec Prism Bright Object Time Series mode, which involves using a prism to spread out light from a single bright object, like the star WASP-39, and measuring the brightness of each wavelength at set intervals of time. WASP-39b is a hot gas giant exoplanet that orbits a Sun-like star roughly 700 light-years away, in the constellation Virgo. The planet orbits extremely close to its star, less than 1/20th the distance between Earth and the Sun, and completes one orbit in just over 4 Earth days. The planet's discovery, based on ground-based observations, was announced in 2011. The star, WASP-39, is roughly the same size, mass, temperature, and color as the Sun. The background illustration of WASP-39b and its star is based on current understanding of the planet from Webb spectroscopy and previous ground and space-based observations. Webb has not captured a direct image of the planet or its atmosphere. This illustration shows what exoplanet WASP-39b could look like, based on current understanding of the planet. WASP-39b is a hot, puffy gas giant with a mass 0.28 times Jupiter, 0.94 times Saturn, and a diameter 1.3 times greater than Jupiter, orbiting just 0.0486 astronomical units, 4,500,000 miles, from its star. The star, WASP-39, is fractionally smaller and less massive than the Sun. Because it is so close to its star, WASP-39b is very hot and is likely to be tidally locked, with one side facing the star at all times. Data collected by Webb's near-infrared spectrograph show unambiguous evidence for carbon dioxide in the atmosphere, while previous observations from NASA's Hubble and Spitzer space telescopes, as well as other telescopes, indicate the presence of water vapor, sodium, and potassium. The planet probably has clouds and some form of weather, but it may not have atmospheric bands like those of Jupiter and Saturn. This illustration is based on indirect transit observations from Webb as well as other space and ground-based telescopes. Webb has not captured a direct image of this planet.